So this is a quick presentation about this hub I developed and why I did it and what it can do. Because I mean, you can buy USB hubs everywhere. Why for cheap? Why would you want this one? Why would I want this one? And it all started with the SysmoQ mod. This is a product from Sysmocom where you have 4 modems on it. Very useful to test roaming cases and have plenty of connections. And I was developing on it. If you see on the back, we have 3 main chips. We have 2 times SIM trays and 1 USB hub. And I worked a tiny bit on SIM trays and tried to improve it on this product too. So we have 3 things, and so you have already 2 SIM traces, and each of the SIM trays has a JTAG port and a UART port. So UART for printf debugging and JTAG for assembly debugging. Here I soldered points. There are normally tag connects, but tag connects are expensive, they break easily, and they stand too high up. So I just soldered permanently some cables. Don't wonder if it looks hackish. It's a development prototype. And you already see that we have 2 devices. Per device, we have at least 2 connectors. That makes 4. And we have even more because I have 1 SIM card reader for remote SIM testing. I have a relay control, which enables me to switch on and off the power to this Q mod. And then I have also, well, the device itself. You see on the right, there is a connector, the USB connector, to connect to this USB hub. So I can talk USB to the SIM trace and for the 4 modems. So just for developing this product, I already need a 7-port USB hub. By itself, it's not too much of a problem because USB, you can have up to 128 devices. I only need 7. The problem are not the number of devices. The problem is that when I connect my USB hub, I get this. So the USB devices are not listed, and I get this message in the journal logs. USB hub nested too deep. This is something which is a bit less known. You probably most of you have 128 devices, but USB also defines how deep you can go in the hierarchy. That's the bus topology, and because of timing constraints, you can have only up to 5 hubs between the host, the computer, and the device. And I was reaching this limit. Why was I reaching this limit? Because my setup looked like this. This is a simplified diagram, but I didn't use a dedicated computer to develop on this thing. I just use my normal computer, which I develop everything on, and other electronic projects. And you see, we only have 3 hubs, and it already complains that we have 5 hubs in the chain. So what's happening? So let's debug it, and to debug it, you just disconnect everything and you look at the USB hubs. And to see the hierarchy of USB, there is the lsusb command, and if you provide the -t, you will see the tree, so which is connected, and then you can go deep down. And with everything disconnected on my laptop, we see that we already have a hub, the root hub. It doesn't count as a hub, but that's the starting point. The bus always starts with a hub. And within the computer, I already have some video capture camera and Bluetooth USB. But this is on a different port. This is when I connect the first hub, and then when I connect the second hub, we already see this topology. And if we count correctly, we count in the chain already 4 hubs. And that's the problem, because these devices are not only 1 hub, but they're 2 in 1. And you see the marking I added on top of it, 1, 2, 3, 4. These are the ports which you can see back here, port 4, and then port 5.1. So port 5, port 1. And if you look here correctly, you would see that I'm connected to 5.1 somewhere, or the next one. So this is how I marked it. Port 1 is from the first hub, and then on the first hub, port 4 is a second hub. And if you look inside one of these USB hubs, you see there are 2 chips. Well, the 7-port USB hub is actually 2 hubs, 2 times 4, and 1 of the first 4 ports of the USB is connected to the second one. This is why we have a hierarchy of 2 hubs every time I connect just 1 hub. I've bought a lot of USB hubs because I reached this limit pretty fast. And there are some very old USB hubs which are actually 7 flat ports, so not 2 times 4, but it's getting very rare. Even the expensive one, they get weird thing. And if you look at it also, the one on the left, it says HID. So this, and you see it also here, the human interface device, the hub even has a human interface device within. I think this is for firmware upgrade, but I'm not, I don't really know. It's in the hub itself. It's not my mouse or my keyboard. So to cope with that, and because I wasn't able to find 7-port flats, which I could readily buy, and the old one were just getting out of stock and not available, I decided, well, design my own USB hub. And these are the requirements. The first requirement is it has to be 7 ports flat. And this way, I won't reach this limit of 5 USB hubs in the chain too fast. This is another USB hub, which is extremely cheap, but I liked it because of the switches. You can toggle on and off the power. And if you look at it, it is very inexpensive. So you see the markings in the middle, C5, C6. This is where capacitors should be to kind of, on every of the output, you should have a capacitor. So whenever you switch power, it doesn't drain completely the power from the USB hub, but this small reservoir provides a bit of enough power so it can start. But on the top, you see that the PCB, there are no routed, no traces, no copper. All the copper and all the lines are on the back. And this is not how you do differential routing. So USB uses differential signals. And for differential signals, you should have impedance control traces, traces which are routed in parallel with the same length, not too far from a ground plane, which is just below it. And this is not the case here. USB 2 is quite robust and it's not a super high-speed signal. So you can create USB hubs without impedance control. The problem with when you do that, or when you're using USB cables which are not very good quality, not very well shielded, is that sometimes when you look in the logs, you see errors like this. And then at some point, the hub will tell that there is an EMI problem, electromagnetic interference, and will disconnect this, this device, or just cannot submit a UART. So this is a USB packet. And when you are testing devices, and you're developing the USB stack or doing something else, this is the last thing you want. Just a USB hub which is crappy, which loses data, and then you don't know, is my code on the device that developed crappy and loses data and uses packets, or is it the cable, or is it the hub? So the next thing I wanted to do is proper routing, so we don't have these EMI problems and no packet drops and no USB reset connection resets. But what I liked on this is that you can switch on and off the power individually for each of the devices. So let's keep this. Let's keep this feature, have each of the ports switchable power output with some kind of indication. And it's useful, for example, if you have plenty of USB to serial devices, but your script only talks to the first one it sees, TTY ACM 0 or TT1 USB 0. So you can switch off and on manually which one of the USB to UART converter you have, so you have the right sequence. The next thing is that USB, at least USB 2, can draw 500 milliamps max, should draw 500 milliamps max, meaning the USB can only draw 500 milliamps if it's only connected to USB. And then all the downstream ports, so the 7 devices I would connect to it, also draw 700 milliamps. And that's not possible. You cannot have 7 times 500 milliamps drawing all the energy from the upstream port, which is only 500 milliamps. So what you do is you add on bigger hubs is you add a power input for 5 volt, and this allows distributing power to the other devices. And here it's 3 amp because it's very rare that you have 7 at the same time which draw 700 milliamps, which would be 3.5 amps. So 3 amps is very generous and should work. This is also what I want, an external power supply. That's not an issue. The other thing I wanted is the QMod operates at 12 volts, and to switch on and off the board, because once, for example, you configured the firmware, so the USB hub starts and so on, you very often have to switch on and off the power of the target very often. So this is very often the case for device testing, or just because it hangs. For example, if you do continuous testing, sometimes the device hangs. You want to be able to power on and off. So what I created is just a relay which I can control using a tiny microcontroller, and this would allow me to switch on and off the power of the Sysmo QMod, and I could control it over serial. I want this feature also being able to control high voltage. Well, high voltage. I call it high voltage because it's 5 volts. It's above 5 volts. But anything which is 12 volts, 24 volts should be able to be switched by the USB hub. And the other advantage is that when you reuse the 12 volt, which I would switch the target device, testing device, is that getting, so the previous device, you see 5 volts, 3 amps. This is, you don't find a lot of power packs which provide 5 volts, 3 amps. This is not something very usual. But 12 volts, 2 amps, or 12 volts, 3 amps is really standard power supply. They're used for LED lights. They're used for plenty of other things. It's really easy to get 12 volts and then 2 amps or 3 amps. And because we already have the power to switch on QMod, why not use it to also regulate the 3 amps or the 5 volts, which are used by the hub? So we have an embedded voltage regulator, which also uses the 2.5 amps or 3 amps for the external power supply. Another feature which you might have heard of is that with USB, you can actually switch on and off the power of the ports remotely. This is within the USB hub specifications. You can have several configurations. The USB hub can say, okay, I have one switch for all the ports, or I can have a switch, or I can switch the ports individually. And there is a tool called UHub Control, which does exactly that. It scans for USB hubs with power capabilities. And you see on the right, next to 7 ports, you see PPS, power per port supply. And you can submit USB requests to switch on and off the power. This is what I do here. I switch off the power. I request information. The power is off. I switch back on the power. And it's very useful to, if you are doing device testing over a long time, overnight, or whatever, because you want to find a bug, you want to be able not only to manually switch on and off the power, but also to have it remotely switch on and off the power. Also very useful if you're putting all your device testing in an enclosure where you in a remote location when you don't have access to it. And the UHub control tool allows to do that. A lot of USB hubs, so all the USB hubs supported this feature. Newer USB hubs are really rare. I don't see a lot of them which support this feature. My USB hub should do that. So individually, and important, it was individually controlled power hub, and they would also control the high voltage. And this is what my hub looks like with all these features. There are a couple of other features. So this is the top. This is what you see from the top. We have a USB input, USB 2, very robust Type B connection. You have 5 volt input if you want to just provide 5 volts. You can also use the 5 volt provided by the USB, but then you cannot power all the downstream ports. And you have a high voltage input. Actually, it's something above 5 volts up to 40 volts can go in there, and then the voltage regulator will take care of it. And the advantage is that the high voltage input is also output at every of the downstream facing ports. You have a high voltage input directly connected to that, but you can switch the power on and off. So when you switch the power on and off to the USB port, it also switches the power on the high voltage side, what I call high voltage. Very often it will be just 12 volts. Other feature it has is a speed indication. So you have 3 LEDs. The green LED will tell you if it's on and off. So either you control it remotely or the switch. So you still have physical control, and the physical control overrides the software control. And then you have 2 LEDs, red and blue, which indicate if it's a high-speed device, so 480 megabits, a full-speed device, 12 megabits, or a low-speed device, 1.1 megabit per second. Generally, mice and keyboards are low-speed device. Most of the devices I've developed are full-speed device, and then you might want to have a USB card reader on high-speed device. This is a USB 2 hub, not USB 3 and not USB-C, because for device testing, I mainly develop with USB 2. It has also lots of protections, because on device testing, you don't know if you soldered everything correctly, so you put a lot of protections. We have feedback protection, so whenever you connect 5 volts or 12 volts, it will not be fed back to the 5 volts, or it will not be, if you plug in the 12 volts, the high voltage, it will not be fed back to the 5 volts. So actually, if you connect your hub to another hub, the 5 volts you inject inside will not flow back to the upstream port and then to the hub. There is also a hard current limit with a polyfuse, so for 0.5 volts. So the hub will never be able to draw more than 500 milliamp on the USB. So this is standard compliance. So whatever happens downstream will not affect upstream, because the fuse will take in place, and then the other devices you have on other hubs won't fail, because this is what was happening at some points. I had shorts on devices I was testing, and my whole USB devices or stacks were collapsing because USB hubs would be resetting. Thanks to this fuse, that's not the case. That's on the input protection. On the output, we have similar things. We have a current limit, which you can set. I set it to 500 milliamps because USB 2 allows 500 milliamps. USB 2 is, I think, 900 milliamps, 800 or 900, I don't know. But I'm using USB 2 only. And this current limit ensures that you never draw more than 500 milliamps. And if a device on the downstream facing port, which I'm testing, draws for more than 500 milliamps, it means there is an issue. So it shouldn't do that. And there is a protection against that. So it doesn't reset the whole USB if it draws more than 500 milliamps, because this protection is in there. You can change it by changing the resistor. What it also does is overcurrent sensing. So it reports to the USB hub if you're drawing too much current. There's a limitation to that. I'll speak about it later. But what it does, at least how the USB hub reacts, if this limit is reached of 500 milliamps, it will switch off the power immediately. So you don't have a device which all the time draws 500 milliamps because it's a short. So I think 10 milliseconds after this current limit has been set, it will switch off, and 100 milliseconds afterwards, it will try to switch on again the device. The other important part there is that I have ESD protection on all of the downstream and upstream facing ports. When you're handling USB devices, these are very often bare boards, and it might happen that you are injecting some ESD because you're touching on the USB, you're touching on the pins, and so on. That didn't happen too often, but what happened though to me a couple of times is when I connect devices, for example, on the screen, on the USB screen, on the USB hub, which is on the screen, the ground potentials were connecting and then a bit of current was going through. So on the, for example, on the laptop which you're connecting, the laptop is floating, it is not connected to mains earth. If you're using the hub of the USB, if you're using the hub of your display, it is very likely connected to mains earth. And if you're connecting multiple floating power supplies and then connecting it to the computer, you might have current which flows to the ground. So you have this different ground potential which would equalize. This ESD protection also protects against that, so you don't have 200 volts different ground potential which gets in sync. It gets burned, you need to change it, but at least your device is secured. And what's important is that if one of the devices is blown, all the other are unaffected, because it's directly blown at the downstream facing port. So you don't damage all the other prototypes you have and you are developing on. Same thing for the USB upstream. You don't want it to damage your laptop or the USB on the laptop or on other devices. And that's all the features it has. And all of that, I also created a case. It's quite large because it has plenty of power outputs. But there is also a 3D printed case, a cover, which is USB, which is laser cut. And you can feed it with simple 12-volt power supplies. Limitations is that it's USB 2 only. I didn't care about anything else. It's not very compact to USB hubs. So the overcurrent reporting, this chip, which is actually the same that it's used on the QMod, has kind of an issue. The USB hub could report that there is no overcurrent. In this case, it will not report it because it only reports it if the overcurrent signal is held on for more than 3 seconds. Now, the overcurrent, the USB hub I designed also has switchable power outputs. And what the USB hub does is that it, after 10 milliseconds, it switches off the power. When it switches off the power, the overcurrent signal is not high, is not asserted. So there is no way that for 3 seconds, the overcurrent is on. So the USB hub will never report to the host that there is no overcurrent limit. So that's one of the limitations, but it's because of the chip. You cannot set it. The other one is that I'm not selling it. I just I didn't plan at least to sell it. It is very well documented, but I just built 3 for me, and I'm using them to develop devices. I'm very happy with them, but it's open source. You can get all the USB hub, all the information, schematics, and board layout, and all the documentation, how to flash it and how to use it. Even the cases which you want to print, you can get them on this link. And that's all I have to say about my USB hub in a very short amount of time and very fast. But I'm open to questions with that. Just talk.
Hi,
Hello.
oh, so you go first, Raphael.
No, I just have a question, like, because I had a project in the past that there was a USB hub and with a Raspberry Pi, and it was madness, never worked. Sometimes it worked, sometimes didn't. And the project indeed is really nice. Congratulations. And I'd like to know, I mean, where did you print the board? I did some boards in JLC PCB, and they really have many components in their stock, so it's kind of
yeah. So the board is meant for JLC PCB. This is a 4-layer board. You can get it for $2 or $4. I don't know. It fits within the $2 or $5 margin, and all the parts are. If you look at the BOM, all the parts have a JLC PCB number. So you can order all the parts which are on this board from LCSC, the company daughter linked to JLC PCB, and you can order the PCB directly from JLC PCB.
Oh, that's cool. Wonderful. Thank you.
So my question was, maybe you said it and I just didn't get it. These, as you call them, high voltage ports, they are also switched when you turn off the port, or they are permanently supplied?
They are switched. So you can use the ports either for USB or to switch off the high voltage. And this is how I switch on and off remotely the QMod. So they are switched the same way the USB port is switched. So when you switch the USB off, the high voltage port, which is next to it, will also be switched off.
Okay, makes sense. Thanks.
So you can actually use, if you don't use all the 7 USB ports for USB devices, you can still use the port as a switchable high voltage port.
So being Osmocom and all, you know, about telecommunications, of course, aren't you a little bit sad that it only goes to 40 volt and not to the standard 48 volt that you can find in all the gear?
Oh, yeah. In the beginning, I designed for 60 volts, but having the components for 60 volts is a bit more expensive. And I didn't see a use case for that because each port, so they can only switch up to 5 amps. I never tried switching 5 amps. I tried switching 2 amps. That's without an issue. I never tried switching 5 amps. And I think all the equipment, even at 48 volts, which is telecom equipment, probably draw more than 5 amps. So you shouldn't connect this USB hub to control power output. You should use a relay for that, or an SSC, solid state relay, SSR.